This set of videos describes part 2 of the Coordinating Units instructional sequence. The material is detailed and rather dense. To facilitate viewing, we have split the description into 3 video segments of approximately 25 minutes each. Part 2 of the Coordinating Units of Tens and Ones instructional sequence is designed to develop children's ability to reason efficiently about sums and differences by coordinating units. Activities in this part involve changing the quantity. Here are some examples of tasks. Mrs. Wright has 26 cherry candies. She makes 38 more. How many cherry candies does she have now? Here's another example. Mrs. Wright has 54 lemon candies. She sells 18 of them. How many lemon candies does she have now? The purpose of this part of the sequence is to foster the development of the conceptual basis for solving additive problems involving numbers to 100 by coordinating units of 10 with units of 1. The difference between parts 1 and 2 of this sequence is analogous to the difference between parts 1 and 2 of the structuring numbers sequence. In both sequences, part 1 involves a single quantity, whereas in part 2, the initial quantity is changed. In part 2 of the structuring numbers sequence, people get on or off the bus. In part 2 of the coordinating units sequence, Mrs. Wright makes more candies or sells some. Further, the activities in this part of the coordinating unit sequence follow a similar progression as those in part 2 of the structuring numbers sequence. In both cases, initially students reason by using physical materials and then progress to reasoning using mental imagery. Here, the physical materials are Unifix cubes that students use as pretend candies. The tasks evolve to those where the teacher uses cubes to show the initial quantity, and students imagine how they would solve the problem using cubes. The anticipation activity is an intermediary activity, as we will explain later. In addition to whole class activities, this part of the sequence also includes partner work, where students use cubes to act out tasks within Mrs. Wright's candy shop. In part 1 of this sequence, the children used Unifix cubes as pretend candies to pack up individual pieces into rolls. In this part of the sequence, they will again use Unifix cubes, this time to act out tasks where Mrs. Wright makes more candies or sells some. Children have a supply of Unifix cubes to use to solve the task. Either they work individually or with a partner sharing one bag of cubes. So, children have to understand how to use the cubes as props to act out the story. In our experience, there are always some children that do not understand how to do so. This initial activity has as its purpose to clarify this issue. For example, suppose the task posed is that Mrs. Wright has 26 orange candies. She makes 18 more. How many orange candies does she have now? Children are expected to use their bag of cubes as pretend candies to act out the story. How do children use the cubes? Well, first they get out 26 candies from their bag of cubes. These are the 26 candies Mrs. Wright has. Where do the other 18 candies come from? They also come from the child's bag of cubes, from his supply of pretend candies. Now, most children understand this and get out 18 more candies from their bag to act out this story. But interestingly, there are always some children in the class that do not understand from where they should take the 18 candies. Some take them from the 26 they got out initially. In other words, these children need to understand how to use the Unifix cubes to act out the story. One way to clarify how to use the cubes to act out the story is to act out 1 or 2 tasks as a whole class. In this case, the emphasis is on how to use the cubes to act out the story rather than on the resulting quantity. After getting out the initial 26, the teacher can ask the class, From where can we get 18 more candies? In the discussion, children will talk about how the bag of cubes is essentially a set of props for acting out the story. This discussion may need to take place with several different tasks on several days to ensure that all students understand how their actions with the cubes shows what happens in the story. In our experience, teachers typically show great creativity in figuring out how to make sure children understand how to act out the story. Likewise, children need to understand how to use the cubes to act out a story where a customer buys some candies. For example, suppose the task is that Mrs. Wright has 42 lemon candies and a customer buys 29 of them. How many candies does Mrs. Wright have after she sells these? How do children use the cubes to act out this story? First, they get out 42 candies from their bag of Unifix cubes. Next, to show that a customer buys 29, they have to take 29 cubes away from those 42. Now, most children understand this and act out the story appropriately without any difficulty. However, there are always some children that do not understand that the 29 should be removed from the 42. Again, one way to clarify the story for these children is to act out one or two tasks as a whole class. In this case, it is useful to have one student act as Mrs. Wright or one of her workers and another to act as the customer. Doing so typically serves to clarify how to use the cubes for those students that are unsure. And again, in this case, the emphasis is on how to use the cubes to act out the story rather than on the resulting quantity. This instructional activity, reasoning about sums and differences using Unifix cubes, will be used for many lessons. It is a whole class activity. Children work individually or with a partner to use their supply of Unifix cubes to act out the story the task describes and to figure out how many candies Mrs. Wright has now. We repeat the examples we have given before. Before we discuss what children do to solve tasks like these and how their learning advances over time, I want to discuss only the first part of acting out the task, getting out the initial quantity. There are several different ways the teacher might pose tasks like this. Here's what I mean. To pose the task, Mrs. Wright has 26 cherry candies. She makes 38 more. How many cherry candies does she have now? The teacher might show, not flash, but show the initial quantity using visual materials like this, and then say, these are the cherry candies Mrs. Wright has. She makes 38 more. How many does she have now? Use your pretend candies to show this story and to figure out how many Mrs. Wright will have after she made the 38 more. In this case, the teacher leaves the image visible for students to see and writes, makes 38 more, so students can remember the task. Or the teacher might pose the task entirely orally, but write the quantities for children to see so they can remember them. When the teacher poses the task using a visual image to show the initial quantity, what we see is that all of the students get out their pretend candies in the same way, using rolls and pieces as shown. However, when the teacher poses the task entirely orally, children do not necessarily show the initial quantity as rolls and pieces. The way they get out the initial quantity is often very revealing and can help the teacher understand something about the children's current conceptions of tens and ones. We will consider several examples of students' activity when the task is posed orally, using examples taken from classrooms that we have visited. The first step in acting out this task is to get out 26 candies. This will be relatively easy by now for the majority of students. They will get out 2 rolls, 2 sticks of 10, and 6 pieces, 6 individual cubes. Some will get the 6 pieces by breaking off 6 cubes one by one from a stick of 10 while counting 1, 2, 3, 4, 5, 6. Others might get out the 6 pieces by taking a stick of 10 and breaking off a group of 4, leaving a group of 6 cubes snapped together. We will come back to say more about this later. Some of our least sophisticated students will use a different approach to get out 26 candies. Sam gets a stick of 10 out of the supply of cubes and counts from 1 by ones, 1, 2, 3, breaking off a cube with each count until he gets to the end of the stick. He is at 10 in his count. He then gets out another stick of 10 and continues counting by ones, 11, 12, 13, 14, again breaking off a cube with each count until he gets to the end of his next stick. He is at 20 in his count. He then gets out yet another stick of 10 and continues counting by ones, 21, 22, 23, 24, 25, 26, once again breaking off a cube with each count. Sam now has a pile of 26 individual cubes. He has 26 candies, but they are all individual pieces. He has 26 ones. Here's another approach we have seen from our less sophisticated students. To get out the initial 26, Danielle gets a stick of 10 out of the supply of cubes and counts from 1 by ones, 1, 2, 3, all the way up to 10. But she does not break the cubes apart. Instead, she leaves them snapped together. She gets out another 10 stick and continues counting by ones, 11, 12, 13, all the way up to 20. She snaps these 10 cubes onto the 10 she already has, resulting in a long stick of 20. She then gets out yet another stick of 10 and continues counting by ones, 21 and 22, all the way up to 26. And snaps these 6 cubes onto the long stick of 20 to yield a very long stick of 26 cubes. Danielle has a group of 26. She has 26. Both Sam and Danielle are thinking of 26 as ones. The difference is that Sam has a pile of 26 ones, whereas Danielle has created a single entity, 26. Neither child has organized the 26 candies into 2 10s and 6 ones, even though the Unifix cubes they have in their bags were already packed into sticks of 10. In other words, they were unable to use the 10 structure imposed on the cubes in their bags to help them get out 26 cubes. I am confident that if we were to ask Sam or Danielle how many cubes are in one 10 stick in their bag of supplies, both of them would answer 10. But we can see from what they did that they are not able to use the information that there are 10 in one stick. They are unable to conceptualize 26 as 2 10s and 6 ones. For them, 26 is 26 ones, or a single entity of 26. Teachers will notice these vast differences in the ways students work with the cubes. These differences reflect the children's current understandings of 10. Let me say more. Children's concept of number begins in grades K and 1 by thinking of a number as one more. That is, 5 is one more than 4. 6 is one more than 5. 11 is one more than 10. 12 is one more than 11. 24 is one more than 23, and so forth. In this early conception of number, 10 does not yet hold a preferential status. For example, at this stage, the child does not think of 12 as 10 and 2 more, or of 23 as 2 10s and 3 1s. So a huge conceptual advance that needs to take place is for the child to overlay a 10 structure on the existing 1 structure. One step in this development is for the child to be able to think of number in terms of 10s and 1s. For example, to think of 12 as 1 10 and 2 1s, or of 23 as 2 10s and 3 1s. This is where the initial scenario of the candy shop comes in. In an attempt to be efficient in counting out candies, Mrs. Wright packs candies into rolls, packing 10 individual pieces into each roll. Now, at first glance, conceptualizing any quantity in terms of roles and pieces appears to be a relatively easy development for children to make. And it is one of the advances children make as a result of part 1 of the coordinating units sequence. In fact, as a result of working with the activities in part 1 of the sequence, most of the children will put out 2 roles, sticks of 10, and 6 pieces if you ask them to show 26. Almost no one will still count the cubes by ones to get 26. However, when we see children able to get out 26 as 2 roles and 6 pieces, we can be deceived into believing that they now have a true understanding of place value, more specifically of coordinating units of tens and ones. It's when we watch what happens next that we can discern the differences in understanding. The next 2 examples are among those I have witnessed across a variety of classrooms as children work with making more or selling some candies. They are illustrative of the ways children engage with the tasks and reveal the wide range of understandings children in any class have at any time. Example 1. The teacher posed this task by showing the initial quantity as a visual image as shown here. This is what Joe and Michael did. They got out 4 rolls, 4 sticks of 10, and 3 pieces. Then they got out 19 cubes one by one, breaking off one at a time from the 10 sticks that remained in their bag of cubes. In doing so, they broke apart an entire 10-stick, a roll, and then continued on using another stick of 10, another roll, counting, as they said, 1, 2, 3, all the way up to 19. The 19 pieces were lying on the desk a bit apart from the original 3 pieces. Here you see a picture of what it looked like. Next, they counted out 10 pieces from the 19 and packed them into a roll. Then they counted out the remaining 9 pieces from the pile of 19, took 1 piece from the original 3 pieces, and packed up another roll. Then they looked at what was lying on the desk. Now they had 6 rolls and 2 pieces. They gave their answer, 62. Notice that Joe and Michael had no difficulty thinking of the final result as 62 based on the 6 rolls and 2 pieces. Also, even though they weren't asked, I am confident that they would have been able to say that the initial configuration represented 43 candies. Nevertheless, to get 19 more candies, they did not get out 1 roll and 9 pieces. They got out 19 individual pieces. In other words, these students were not thinking of 19 as 110 and 9 more, or as 1 roll and 9 pieces. I interpret this to mean that Joe and Michael are in a sort of transitional stage. When they see a quantity as shown in tens and ones, such as the quantity they had at the end of the problem, they are able to say how many it is. However, when they are in the midst of working with quantities, those quantities are still conceptualized only as ones. 19 is 19 ones. This way of operating is especially likely when the initial quantity the children have is not a full decade. That is, not something like 40. In this example, the initial quantity was 43. I will say more about this later. By contrast, other students got out 4 rolls and 3 pieces, and then got out 19 as 1 roll and 9 pieces. Some of these children created a pile of 9 ones, while others had the 9 cubes snapped together. Most likely, those that created a pile of 9 ones broke off 1 at a time while counting up to 9, while those that had the 9 snapped together most likely took a 10-stick, a roll, and broke off 1 piece to leave 9. Here again, we see the differences in children's concepts. Those that left the 9 snapped together were thinking of 9 as 1 less than 10. The others were thinking of 9 as 1, 2, 3, 4, 5, 6, 7, 8, 9. In any event, all of these students now had 5 roles. Those that made a pile of 9 ones now had to somehow count out a total of 10 cubes and pack up a roll. They might use the 9 and 1 from the 3, use the 3, 7 from the pile of 9, or if they had pushed all of the ones together, they had to count out 10 from the total pile of ones. In any event, they now had 6 rolls and 2 pieces. On the other hand, those that had the 9 ones snapped together had only to take 1 from the 3 to easily get a roll. As children solve tasks like this repeatedly, 2 ways of using the cubes emerge as most common. We are going to come back to this point later. Now let's consider an example where some candies are sold. Mrs. Wright had 34 peppermint candies. She sold 18 of them. How many does she have now? I was standing next to Amber and Tiffany as they solved this task. They acted out the story like this. They easily got out 33 rolls and 4 pieces. Then Amber gave 18 to me since I said I wanted to be the customer. Here's how she did it. She gave me the 4 pieces, counting 1, 2, 3, 4, and then continued counting, giving me 1 cube at a time, breaking cubes off of 2 10 sticks, 2 rolls, while continuing to count 5, 6, 7, 8, all the way to 18. At that point, I had 18 individual cubes in my hand. She had 1 roll and 6 cubes left snapped together, as shown here. When I asked Tiffany to act out the story, she did the exact same thing. My interpretation of what is happening here is that at this time, Amber and Tiffany were unable to think of 18 as comprised of 10s and 1s if they started out by thinking of 4 ones. If we simply asked them to show 18, I'm sure they would have put out 1 roll and 8 pieces. However, in this case, they each began by giving me 4 pieces, so they were now in the position of having to think about the rest of the 18. And the only way they could do so was to think in terms of ones. Another way to say it is that they were unable to think of 18 as 4, 10, and 4 more, or even as 4, 4 more, and 10. In interviews we use in our research projects, we have tasks that demonstrate this same inability to think in terms of 10s and 1s when you begin with some, but not all, of the ones. Another thing this way of reasoning is that for Amber and Tiffany, 34 is made up of 3 10s and 4 1s, and the 1s are the last part of the 34. Therefore, when they wanted to take away, they were taking away from 34. They took away the 34, the 33, the 32, the 31, the 30, etc. They were not able to think of taking away 18 in parts, such as to take away 10 from the 30 in the 34 and 4 from the 4 in the 34. Others solved this problem by taking away a roll for the 10 in 18, and then taking away 8 more. Most used the approach a student named Destiny used, which was to take away the 4 pieces and 4 from a roll. Even here, there were differences. Some took away the 4 pieces and then just knew they needed to take away 4 more, so broke 4 off of a roll, leaving 6 snapped together. Others took away the 4 pieces and then counted on, while breaking off additional pieces from another roll while saying 5, 6, 7, 8. When asked, those children that did this had no idea how many they had taken from the additional roll. When they were asked, so how many did you take off of this roll? They didn't know. After looking at the 6 cubes that remained and that were snapped together, one of the children said 4. In other words, after the fact, she was able to figure out that it must have been 4. But because of the way she actually carried out the task, she did not know at the time that she had taken off 4. Still other children, like Andrea, took away 1 roll, 8 pieces from another roll, leaving 1 roll, the 2 snapped together, and the 4 pieces they had initially. In discussing examples 1 and 2, we said that children sometimes break cubes off of a roll and leave the remaining cubes snapped together. Now, when Mrs. Wright breaks open a roll in her candy shop, she will end up with 10 individual pieces. There will be no chunks of 6 or other amounts left stuck together. So the children's actions do not exactly mimic what happened in the scenario. Some teachers have asked us about this discrepancy and have questioned whether they should require their students to follow the scenario exactly, so that when they want to take pieces from a roll, they should begin by breaking the roll into 10 individual pieces and then go from there. Our answer to this is a definitive no. Teachers should not require students to break a roll into 10 individual pieces. The reason is this. Remember, the purpose of this instructional sequence is to foster children's coordination of 10s and 1s so that they can eventually reason entirely quantitatively. The scenario is one tool to get to that goal. But the ultimate goal is that children can reason about 10s and 1s quantitatively. The goal is not that they mimic the actions of the candy shop. When children leave cubes snapped together, they often are able to think of them as a group. For example, they may be thinking that if I take 4 from 10, I have 6 left. In doing so, they are moving away from thinking of everything in terms of 1s, thinking 1 by 1, but are thinking in groupings that comprise 10. Insisting that children break apart a roll into 10 individual pieces often puts them in the position of having to count everything by 1s, just the opposite of what we are trying to foster. Similarly, when children get out the initial quantity, they might leave the individual pieces snapped together. For example, if the initial quantity is 16, children might get out 1 roll and then break 4 cubes off of another roll, leaving 6 snapped together. They might do this even if the teacher poses the task by showing the initial quantity visually as 1 roll and 6 individual pieces. Here again, having the 6 pieces snapped together can be an advantage for the child in figuring out how many there are in all after more are made, because he can take advantage of number combinations he knows as he packs up another roll. Having said this, we want to be clear that when the teacher shows a quantity as a visual image for children to see, it is important to show the 1s in some easily identifiable pattern as discussed in part 1 of this sequence. The teacher should not show a quantity of 1s visually as a group of 1s snapped together, because often it is not easy for the children to know in such instances just how many there are without counting them by 1s. We will say more about this point later on when we talk about possible notation the teacher might use to show children's ways of reasoning. The wide variety of ways children use the Unifix cubes to act out the story reveals the huge differences in their underlying conceptions of 10s and 1s. Further, they emphasize the need to use tasks of this type repeatedly. In the class discussions that accompany each of these tasks, there will only be time for some children to explain what they did. After all, there is a limited amount of time in the lesson. But even more, the discussion is not intended as a time when everybody explains his or her way of solving the task. Rather, the discussion is intended as an occasion for learning. It is the teacher's responsibility to orchestrate the discussion so that everyone has an opportunity to advance in their understanding. And the advances children make depend on where they are currently in their conceptual development. We know that not everyone will get to some predetermined point of understanding after solving and discussing one or two tasks. But the teacher has the opportunity to observe how children use the cubes as they act out the story. And she can use that as the basis for deciding which children to call on to explain how they solved a task. And it is her responsibility to ensure that the discussion is meaningful for everyone. In the case of the second example, the teacher might say, Amber and Tiffany took away 18 by first taking them one at a time. But Destiny thought of 18 as one roll in 8 pieces. She took away a roll first. That's 10. So now she had to take away 8 pieces. The teacher can then go on to call on someone by name and ask, Maria, what do you understand about how Destiny figured this out? As the discussion progresses, the teacher will find out how the class as a whole reasons and also how individual children reason. And as the discussion progresses, the children will progress in their understandings as they attempt to make sense of what others say. As you can see, the discussions of tasks are not intended to check to see if the children got the correct answer, but are about how children advance in their learning and about what the teacher learns about their advances. This concludes video segment 1. Segment 2 continues the discussion of reasoning about Unifix Cubes activity.